All right, guys, let's do Unit 8, Lesson 1 homework on rates. Well, we understand you have to watch the lesson. Pretty much the first page is the lesson, and I want you to fill it out. I'm not going to fill it out. You have to watch the lesson to fill it out. So we know everything about calculus. We know about going forwards. We know about going backwards, and we know the new thing. The big new thing from Unit 7 was accumulating. Accumulating a derivative gives you a displacement in your total. Accumulating something you can find by using the antiderivative. The key is when you're given a derivative, what happens when you accumulate? You'll get a change in the total. So fill out this entire thing, and that shows me you watched the lesson. All right, I gotta give some people some quizzes and some tests. All right, so in this problem, we have a rate at which water is flowing into a pipe in cubic feet per hour. We have a rate at which water is going out the other end in cubic feet per hour. What we realize is that these fall on the derivative column. That R is a rate in cubic feet per hour, as well as D. Cool. We know that we have to accumulate these to get a total in, but really what we find is that since we understand that an initial amount plus a total in minus a total out makes sense, we realize that our derivative is just the rate in minus the rate out. And we're going to go ahead and just start straight here. P prime is R minus D, or my velocity is R minus D. Pausing. Yeah. Cool. So like for these questions, since you have your calculator, we're going to use decimals a lot. And you are going to want to have R, have D, but more importantly, have V, which is R minus D. So I'm going to type in, as I see it, R. I'm going to start to restrict R and D. That way I don't have to see anything extra. Restrict this from 0 to 8. Cool, this is great and all, but I really want the velocity of my situation, the derivative of my situation, R minus D. And I'm going to hide R, I'm going to hide D. I might use them, but I'm just going to look at R minus D. I'm going to adjust my graph settings so that I can see from 0 to 8. So I might as well just go from -1 to 9. And then I'm going to see that I can pretty much see my velocity here. If I zoom out just a little bit, I'm probably good. And there you go. There's my velocity. All right. But be careful. You might not always be using P prime, R minus D the entire time. For example, part A says how many cubic feet of rainwater flow into the pipe. Since you want the total in, you want the cubic feet in, you're going to have to accumulate R to get the total in. You don't plug in 3 into R, or you don't plug in 8 into R. 8 plugged into R would give you your cubic feet per hour, how your total in is changing, or the rate at which it's flowing in. So I'm just going to accumulate from 0 to 8 R. And that tells me the total amount in. Awesome. Good luck.
Thank you.
Do you mind if I'm talking math in the background? Do you mind if I'm talking to myself in the background? All right. Okay, so this is 76.570. I accumulated R to get cubic feet. This is cubic feet. It's not cubic feet per hour. That would be R of 8. And then here, B, this is important to understand, like what you have. You have derivatives. Is the water level in the pipe increasing or decreasing at 4? You're looking at how P prime is. Is P prime positive? Is P prime negative? If P prime is positive, that means the water level, which is your position of the situation, your water level is increasing or decreasing. We want P prime of 4. Well, P prime is V, which is R minus D. Now, it's very easy to do this if you already have V graphed. You just say, what's V of 4? I'm not going to look at V prime. V is the derivative. V is the derivative of the position. You can look at the value at 4. You know the units are cubic feet per hour. So there's your value, 1.147 cubic feet per hour. Cool, 1.147 cubic feet per hour. Slow. Now, how do I know it's cubic feet per hour? Because I'm plugging values into R and D. R and D are derivatives. They are rates of change of position. What would I do to explain this value is I would say that my water level is increasing by this many cubic feet per hour at T equals 4. At this moment in time. Is the rate that the water level is changing, increasing or decreasing at T equals 4? We are looking at the rate the water level is changing, whether it's increasing or decreasing. We would want to know the second derivative's value. We want to know P double prime at 4, which is V prime of 4, which is R prime minus D prime. You don't have to write that, but you could. And if you do V prime of 4, or if you look at your graph at 4, you can see like my velocity is increasing. If I look at the derivative here, you should see a positive value, 1.862. What up, Mega?
I'm here to take a bio quiz.
Great. Mr. Gerhardt?
Yes.
Need this. Don't write on it because I need it back. Sit over there so I'm not talking in your ear. Good luck. Cool. Now, what did we do? We took a derivative of our velocity. When you take a derivative of your velocity, you will get an acceleration. You'll get a cubic feet per hour, or a cubic feet per hour squared. What's your explanation? Well, a second derivative tells you about your first derivative. So first of all, correct units, cubic feet per hour, how your cubic feet per hour are changing. You would say the rate of change of the water level, which is P prime, is increasing by this many cubic feet per hour, or cubic feet per hour squared. All right, when is the water in the pipe at a minimum? All right, let's look at our derivative from Desmos. Let's look at our velocity. Let's look at r minus d. We'd see it's negative until here, and then it's positive afterwards. We know that must be the location of the minimum. I don't have to really do much checking of candidates. This is when like doing a little bit of analysis helps you. P prime is negative until A, it's positive afterwards, which means P is decreasing, then increasing. So T equals A is the minimum because P prime is negative from 0 to A, and P prime is positive from A to 8. I probably want to find the amount. I'm going to ask you for the amount. So I'm going to make sure you know how to find the amount. Well, my total at A will be my initial amount of 30 plus, I can't take an antiderivative, so I'm going to accumulate my derivative from 0 to A to find out how much I decrease. So I'm going to find this number to figure out how much P decreases. And I know that I started with 30. And then I'm going to subtract this amount. So 0 to A, I got to write down what A is. 3.27166. Make sure I've written down that P prime is R minus D, which I did, or I could say V is R minus D. You have to have this written down somewhere. That way you're not just throwing letters out there at random. And I'm going to go ahead and accumulate from 0 to A my V. I can see I decreased this amount. If I start with 30 cubic feet and I decrease that 2, I will have a position of 27.964 cubic feet. Let's see if that shows up. It's so slow. Yeah, it didn't show up. It's actually pretty close. 27.964 cubic feet. Great. Same type of situation where we have this like consistent rate in and rate out. We're talking about fish migrating in and out of a lake. We got fish entering, fish leaving, fish per hour. There were 500 fish at the beginning of the day. All right, cool. So just going to kind of put my chart over here and understand that. Really understand your units is important. So your position, how your position's changing and how your change is changing. Your position would be fish. Your rate of change of your position would be fish per hour. And your rate of change of your rate of change would be fish per hour squared, or fish per hour per hour. Cool. E and L are rates of change. So you have to accumulate them to get totals. You could say that E minus L is the derivative of your situation. Incorporating your rate in, your rate out, boom, rate in minus rate out. We have that there's 500 fish at time 0. We know we'll have to accumulate our fish per hour to get fish, accumulate E to get total fish that have entered the lake, accumulate L to get the total fish that has entered that have left the lake, accumulate V to get just the displacement of your total fish. So for A, I know I'm just going to accumulate E to get your total fish in. For B, I'm going to write that P prime equals V, which equals E minus L. For B, I'm just going to do 500 fish plus from 0 to 9 my velocity, or my P prime. C, D, E, we will have to do. So let's go ahead and just break out Desmos and start doing some stuff. We're on from I feel like we're going for like 24 hours, so I don't want to like restrict this at all. So I'm just going to say E is 20 plus 15 sine pi t over 6. L is 4 plus 2 to the 0.1 t squared. I don't want to see those. I want to see them at the same time. I do want to see these. Ooh. Okay, maybe we're not talking about all day long because it looks like my derivative is negative and getting more negative, which means, I mean, what does that mean is the question. You should understand that. For part A, I want to accumulate from 0 to 5 my rate at which fish are entering to get my total fish entered, 153.457. It's a model, so like don't be worried. Don't be worried about a decimal. What's the total amount of fish at 500 at t equals 9? Well, I started with 500, and then I'm going to accumulate V from 0 to 9. And I realize that I add a bunch of fish, but then I start losing fish. Right now, I'm losing more fish than I'm adding, obviously, because my derivative is negative. And after 9 hours, I'm at 423 fish. And this is my position at time 9. What's the maximum amount of fish in a lake? Well, here we can see at this value, which I'll say is A, the derivative changes from positive to negative. So we can understand my derivative is positive until A, and then it's negative after A, which means the total amount of fish is increasing and decreasing. So the max fish occurs definitely at t equals A. Should write down what A is equal to 6.20356. Because P prime, you could say V is positive from 0 to A, and then P prime is negative from A to the rest of time. Okay, and then what is the maximum amount? Well, P of A equals that 500 plus that accumulation of my derivative to figure out how much I increase. Whether you use P prime or V, it's the same as long as you have it listed out. P prime equals V up here. You can decide to use E minus L if you wanted to. It's up to you. So I'm going to say 0 to A. Max amount of fish, 635. 0.014 fish. Cool. Fish, accumulating my fish per hour times hours. Fish per hour times hours gives me fish. Is the rate of change in the number of fish in the lake increasing or decreasing? Pay special attention to how this is worded. Is the rate of change increasing or decreasing? I need to look at the second derivative. I need p double prime at 5, which is v prime at 5, which is e prime minus l prime. I want to see at 5. I can see that my rate of change, like what is this that we're seeing? It's the rate of change in the number of fish. I can see the rate of change is decreasing. We want the specific value, so I'm going to do v prime of 5. That is the rate at which this is decreasing, negative 10.722. What are the units? It's an acceleration. It's fish per hour squared. It's the rate of change of the rate of change. It's fish per hour per hour. So the rate of change is decreasing by 10.722 fish per hour squared, or fish per hour per hour. The model persists. Will the lake ever run out of fish? I mean, I can definitely say yes. You see that your derivative is negative and will continue to be negative. What's an easy justification? I mean, let's just go out to like 12 hours. Yeah, so after, I mean, like, it is going to be hard to find the exact time. So I don't want you to like guess and check. It's like somewhere between 9.8 and 9.9 hours in. You can literally say yes. At t equals 10, p of 10, which equals 500, plus your accumulation of p prime, gives you negative 137 fish, which is impossible. Your fish level must hit 0. You could say since v is continuous, p at some t must equal 0 at some point. Or you could just like say you can't have negative fish, you must hit 0. All right, cool. Now we get into rates in or out changing over intervals. It's a very timely question. We got Janet, who is shoveling snow. Janet sees that snow is falling or accumulating on the driveway at the rate of that in cubic feet per hour. And then Janet starts removing snow at g cubic feet per hour. Wow. I'm going to close this off and open it back up. This is rough. Computer's slow today. Can I do like optimal performance? I need to restart. That's what I want to do. I don't want that. I want best performance. Please give me my best performance. Maybe that'll help. All right. Cubic feet per hour in. Being snow. Oops. Cubic feet per hour out. We have position, velocity, acceleration. Position would be the cubic feet of snow. My velocity would be that cubic feet per hour, and my acceleration would be cubic feet per hour per hour. We understand that both F and G are rates of change, which means if you plug in values into F and G, you get cubic feet per hour. If you accumulate it, you'll get cubic feet. If you take the derivative of it, you'll get cubic feet per hour squared. Thank you. Oh, this is pretty. Nice penmanship here, Margot. Yeah. Now, what's going on here? Well, we have a lot of velocities in play over different intervals. This is where restricting intervals are going to be so important. So let me show you how we do that. And we kind of did it for the first problem. We have this rate in. We have three G's. We have this first G from 0 to 6. We have the second G. So I just type in 2 after you type in G, and it immediately subscripts. We have this third G. Now, if f minus g is our derivative, we have three derivatives. We have our first derivative, which will be over my first interval. We have our second, which will be over the second interval. And we have our third. I'm going to hide these. That way I can see the situation, the derivative. You can see snow is accumulating, so we're adding snow. And then Janet starts shoveling. We can see that the total snow, cubic feet of snow, is decreasing. So the cubic feet of snow is increasing, and then Janet starts shoveling, and the cubic feet of snow starts decreasing. Great. How many total feet of snow? It's accumulated in Janet's driveway from midnight to 6 a.m. Well, I want to accumulate my total my rate added to get my total added. Your cubic feet per hour times hours, 142.274 cubic feet of snow. I don't know if that's a lot of snow. Was the total amount of snow on Janet's driveway? Well, I started with 0 snow on the driveway. And then we could just think about this as what I want to do. However, the only way to do that is to go from 0 to 6 of V1, where V1 is F minus 0, and then add 6 to 7 V2, where V2 is F minus 125. And then from 7 to 9, we have V3. So this is important to understand that we have to separate things out. If you don't, you're not going to be able to get an answer. This makes sense. I'm removing snow. Removing more snow. So I added this amount, then just continue to add the derivative. $26.33. Total amount of snow increasing or decreasing. So is the total increasing or decreasing? Oh, I gotta look at my derivative. My derivative is my velocity at 8. Well, do V of 8, I can see it's like, what are you talking about? If I do V1 of 8, it's like, what are you talking about? If I do V2 of 8, it's like, what are you talking about? Because 8 exists for that G3, and we're talking about over here. You get this negative 59.582. That's just the value of the velocity. That's the value of the derivative. That is in cubic feet per hour. The total snow, not the rate of change, but the total, is decreasing by 59.582 cubic feet per hour. Okay, the next question asks for the rate of change of snow on Janet's driveway. Is it increasing or decreasing? So we need to see how the rate of change is changing. We need to look at the second derivative. The second derivative at 8 is the derivative of your velocity at 8, or the acceleration, which is F minus G. So I need to come here and look at the derivative. All right, so that's how V is changing at 8. So we can see the value of V of 8, and then we found the derivative of V of 8. And that's negative 41.849, which is in cubic feet per hour, or it's an acceleration. So the rate of change of snow on the driveway is decreasing by 41.849 cubic feet per hour at t equals 8. If snow continues to fall at the rate given by F, and Janet continues to remove snow at the rate given by G of T from 7 to 9, will Janet ever be able to remove snow in her driveway? Okay, well, let's just expand this to, I don't know, 24. And let's expand this to like 24. Uh-oh. Eventually, the snow falls at a harder and harder rate. Eventually, the derivative will be positive. Eventually, snow starts to accumulate. So the goal is to figure out if at 11.312 the amount of snow is negative. Because once we get beyond that, I think Janet's screwed. Um, we know that snow on at 9 is 26.334. Okay. So P prime is negative from 9 to this value here. Did I save it? 11.311. Of A equals, I'm just going to go P of 9 plus the accumulation from 9 to A. P prime of V. This is a 9. This is A. Okay. Three. And no. Yes. Yes. We get negative. So yes. Now, probably she'll be able to get her car out and like run away because snow is going to start to add. Like, watch what happens if I go from 9 to 12. Oh, 13. Okay. If I go eventually at the 13th hour, there's going to be more snow on the driveway. But yes. Yes. At some time t between 9 and A, there will be no snow on the driveway. Probably should include P of 9 being positive. 6.334. That P prime is continuous. So that means we're going to have to have all values between 26.334 and negative 120.675 by the intermediate value theorem. But don't stress out about that. All right. Quick pause. Okay. So packages in a sorting facility. Facilities start with 500 packages in the day. A is the rate that packages arrive, and it looks like the rates change at which they arrive. Packages arrived at the sorting facility per hour. Then we have packages being processed. So we got an idea with A. I think I fixed everything. Close. A is a rate of change. L is a rate of change. We have P in this situation. Let's fill out our chart, making sure we understand everything. P is packages, total packages. P prime would be packages per hour. P double prime would be packages per hour or per hour squared. Both A and L are in packages per hour. The velocity of the situation or the derivative of the situation is A minus L. However, A changes. If we accumulate the V, I'll get like the displacement of my packages or how much my packages changed. If I accumulate L, I will get total packages out. If I accumulate A, I'll get the total packages that have arrived. Cool? Great. Two A's though. So A1 is 34t plus 60 cos squared t. And I'm going to restrict that from 0 to 12. It should not be an equal sign both those places. My bad. A2 is negative 4t squirt t minus 12 plus 400. Cool. And I'm restricting that from 12 to 24. So we're talking about a full day here. And then we got packages being processed. So obviously, like due to, I don't know, trucks, planes, we have these differing packages arriving, but the machines that are sorting them, slash the humans that are sorting them, are fairly consistent in the rate at which they sort. This is going all the way from 0 to 24. Great. I'm going to want to look at the velocity of my situation, but I have two velocities of the situations. I have A1 minus an L. My second velocity of the situation is A2 minus my L. And I want to look at this from 0 to 24. So I'll go from like negative 1 to 25. And I'm going to maybe talk about 500 to 500. Oh, yeah. Cool. There are the velocity. That's the velocity. That's the situation. Here is my rate in. Here is my other rate in. So I'm like increasing in the amount of packages per hour, decreasing the amount of packages per hour. Here is how the packages are being sorted. So here is the situation of packages in and out. I feel like I'm going to end with more packages than I start, but let's see. How many packages arrive at the facility? So I actually want to accumulate A from 0 to 24, but I can't do that. I have to accumulate A1 from 0 to 12, and I'll call this A1. And I have to accumulate A2 from 12 to 24. So dt, packages per hour times hours. Accumulate from 0 to 12, A1. Accumulates from 12 to 24, A2. It's a lot of packages. Add this to that. 5,466 packages. The total amount of packages increasing or decreasing at t equals 15. Well, is the total amount increase or decreasing, I have to look at the rate of change of the total. And I have to probably write down somewhere that P prime is A minus L. Arriving, leaving. Cool. Could be FG, could be something else. So I want P prime of 15, which is A of 15 minus L of 15, or you could say this is my velocity. I probably want to understand it's V1. You could write that it's V1 or V2. I don't know which one is 15. 15 is going to be incorporating V2. Ooh, it's a very good question. Can't say V of 15, it doesn't work. Can't say V1 of 15 because it doesn't exist on 15. You have to say V2 of 15. 76.565, you can see that the velocity is positive. 76.568. What is that? Packages per hour. It's a rate of change. It's how the position is changing. The position being packages. At t equals 15. The total packages at the facility is increasing by 76.569 packages per hour. Is the rate of change increasing or decreasing? We need to look at if the rate of change is increasing or decreasing, we need to look at the second derivative. So I want to find P double prime of 15, see if that's positive or negative. So that's V prime of 15. So V prime of 15 is negative 1.458. What are that units? Well, if I take the derivative of P prime, I get P double prime, it gets an acceleration. It's packages per hour, or packages per hour squared. So it's like how my packages per hour are changing per hour, packages per hour per hour. So I would say the rate of change of packages is by 1.458 packages per hour, or per hour squared. Find the maximum amount of packages of this facility over the 24 hours. Well, let's look at P prime. P prime is negative until this value. Let's write that down. P prime. I feel like I have to make the noise now. It's one of those things. Kind of need to stop at 12 and switch it up. But I can see it's like positive until this value. Call this A. Write down what A is. Call this B. Oh, my A's and my nines, guys. Sorry. B is that number. Okay, so that means my total packages are decreasing, then increasing, then increasing, then decreasing. I'm assuming that B is going to be the max. But my candidates, max is at t equals 0 or t equals B because my derivative is negative from 0 to A and B to 24. And my derivative is positive from A to B. Hi, there we go. It is.
Where?
Quiet and
This time of year?
warm. Right, quiet and warm. Well, they were in early. It was busy.
Yeah, that's been busy.
Well, also there's like from Thursday and Friday of last week, just people dropped off these stacks of just like, yes, everybody was absent in my class.
Yeah.
Yes, yes, good luck, good luck. Yeah, ooh, lots of packages. P of 0 is 500, P of B, which is 500 plus I accumulated V1. I really accumulated V from 0 to B, but whatever. If you want to say I did V1 from 0 to 12 and V2 from 12 to B, great. We get that there's 1,494 packages. We need to boost our sorting. So that's the maximum. You can see I'll end the day with less than that. You know, at least I end the day with double the amount of packages that I started with. Cool. This is the idea here, guys. What's the minimum amount of packages? Well, let's check A. We already checked 24. It's definitely going to be A. Start with 500. Oh, I get down to 45, and then the packages start rolling in. So it's cool. This is the max. All right, that's it, guys. That's you know, more real world and more accumulating. So we'll have a quiz next class, and I'm not doing much practice. This is going to be one of those you know it or you don't kind of things. The test of like, can you do the work that I asked you to do? Because you're taking the test today. We'll see. Later.